Hello viewers, still on that limit of function, we are going to solve these two questions. We've done part 1 on limit of functions, and then this is the part 2. In this part 2, we are going to consider a situation whereby we have a question and then x tends to infinity. So let's take the first question, solution. So in this question, we have limit of 4x squared plus x minus 1 all over 3x squared plus 2x plus 1 as x tends to infinity. Now, if we bring in the value of infinity here, we are going to have, if we bring in infinity, infinity here, infinity here, infinity here, we are going to have a situation whereby the solution to this question will be undefined. And because that's not what we are looking for, we have to take another step in order to ensure that it is not undefined. So we have limit 4x squared plus x minus 1 divided by 3x squared plus 2x plus 1 as x tends to infinity. So in order to solve this question, we have to divide both sides, that's both the numerator and the denominator, by the highest power of x. So we say divide the numerator and denominator by the highest power of x. So we can see that from the question, the highest power of x is x squared. So implementing that mathematical statement, we are going to have limit of 4x squared. We are dividing now by the highest power of x plus x, that is this other x, divided by x squared plus, is minus 1 over x squared. So we are done with dividing by the highest power of x for the numerator. And then for the denominator, now we are considering this to be 3x squared all over x squared plus, we take this, plus 2x all over x squared plus 1 all over x squared. So we've been able to implement this mathematical statement, so we can now cancel out. Here will be 1, here will be 1. Note this as x tends to infinity. If you cancel x here, it will be 1, and then you take this one out, and then this will be 1, this will be 1, this will be 1, this will go out. Now let me explain this so that you understand. If we have x all over x squared, it is the same thing as saying x all over x times x. Okay, so when this cancels out, we'll be left with 1 over x. So that's why I'm just cancelling out the 2, and then we are left with 1 over x. The same thing applies here. So that's how it is. So we solve for that. So what we are left with is limit of, this will be, what will be remaining here will be 4, plus what will remain here will be 1 over x, minus what will remain here will be 1 over x squared. As for the numerator, and then for the denominator, we have 3, that's what will be left here, plus what will be left here is 2 over x, plus what will be left here is 1 over x squared. So as x tends to infinity, we can now bring in the value of x, so that we have 4 plus 1 divided by infinity. We are replacing x with infinity now, minus 1 divided by infinity all squared, divided by, we come to the denominator now, 3 plus 2 divided by x is now infinity, plus 1 over x squared, so it will be infinity squared. And so, having done this, we now move on. This will be 4 plus 1 divided by infinity will be 0, because this is heavy bottom. Infinity is heavier than 1, so it will be 0. So we have 0 minus 1 divided by infinity square will still be 0, heavy bottom. So we have 0 divided by, come to the denominator, 3 plus 2 divided by infinity, heavy bottom. Infinity is heavier than 2, so it will be 0, plus 1 divided by infinity squared, heavy bottom. The bottom is heavier than the top, so it will still be 0. So this will give us 4 plus 0 minus 0 will give us 4, divided by 3 plus 0 plus 0 will give us 3. So viewers, in solving this question, this is the answer. The limit of this function as x tends to infinity is 4 over 3. So that is for part A of the question. Let's look at part B of the question. Part B. So we have limit of 1 plus x into 2 plus x into x divided by x cubed plus x as x tends to infinity. So in order to simplify this question, we have to first open up the bracket, open up this bracket where we have the numerator. So we use this one first. So this will be equal to limit of, if we say x times 2, okay, let's say take 1 plus x into x times 2 will give us 2x here, plus x times x will give us x squared here, and then this will be over x cubed plus x. Note this tends to infinity. Okay, we can also open the bracket using this. So this will be limit of 1 times, we want to open up this bracket, 1 times 2x will give us 2x, plus 1 times x squared will give us x squared, plus x times 2x will give us 2x squared, plus 1, okay, x times x squared will give us, okay, let me start again, 1, okay, this will be limit 1 times 2x will give us, this is multiplying this will also multiply this will multiply this will also multiply this. So 1 times 2x will give us 2x, plus 1 times x squared will give us x squared, plus x times 2x will give us 2x squared, plus x times x squared will give us x cubed. So this will be divided by x cubed plus x. Note as x tends to infinity still. So if we look at this, we have like terms, x squared and 2x squared are like terms, so we can add them. So next up we have limit of 2x, x squared plus 2x squared will give us plus 3x squared, plus, then we take our x cubed, and then this will be divided by x cubed plus x as x tends to infinity. Now at this point, we can now divide both sides of the equation by the highest power of x. So we say divide both the numerator and denominator by the highest power of x. So if we implement that, we are going to have limit of 2x, we take the numerator first, 2x, the highest power of x is x cubed. So this will be 2x over x cubed plus, we take this one, 3x squared over x cubed. We take this one plus x cubed over x cubed divided by, we now come to the denominator, we take x cubed, which is this, divided by x cubed plus x all over x cubed. So as x tends to infinity. So we can now cancel out. When we cancel out here, it will be 1. When we cancel this out, it will be 2 that will remain here. We cancel this out, it will be 1. This is 1. And this is 1. Cancel out, this is 1. This is 1. This is 1. And 2 will remain here. Of course, let me show you what happens here so that you understand. If we have x cubed divided by x squared rather divided by x cubed, this is the same thing as saying x times x divided by x times x times x. 1, 2, 1, 2. So we'll be left with 1 over x. That's why we have here to be. Oh, sorry. So that's why we have here to be. This is out like this. And then this will remain. So let me write it properly. X squared 1. So we are left with 1 over x here. The same thing applies here. If we have x divided by x cubed, it's the same thing as saying, if we have x divided by x cubed, it's the same thing as saying x over x times x times x. So 1 cancel out. So it will be 1 over x times x, which is 1 over x squared. So that's why we have this one to be 1 over x squared here. So, having done that, our solution now becomes limit of, what we are left here with is 2 over x squared, 2 over x squared plus, this one will be 3 over x plus, this one will be 1 divided by, this one will be 1 plus, this one will be 3 over x, and this we have, okay, this is 1 plus 3 over x, okay, there's no plus here. So remember, this is as x tends to infinity. So let's complete the solution. Okay, let's complete it here. Let's complete it here. So when we now bring in the value of limit, we are going to have limit of 2 over x is now infinity, so we have infinity squared plus 3 over this 3 all over infinity plus 1, which is the last one here, divided by 1 plus 3 over infinity, because there's 3 over x and x is now infinity, and it's as x tends to infinity. So if we want to solve this, this is 2 divided by infinity square. So we have bottom heavy is heavier, the number here, the value here is heavier than the top, so it will be 0. 2 divided by infinity square will be 0. Then the same thing applies here. 3 divided by infinity will be 0 because it is heavy bottom, plus 1 plus, then 3 divided by infinity still will be 0. We continue. And so from here we have that 0 plus 1 will give us equal to 1 over 1 plus 0 will give us 1. So our answer is 1. So in solving this problem, the limit of this function as x tends to infinity equal to 1. So viewers, this is how to approach the problem of limit of functions when x tends to infinity. This is the part 2 on the topic limit of functions. You check out for my video on part 1 of this topic. Thank you.